Today we're talking about solving exponential equations where the variable is in the exponent. Okay, basically the whole point of this today is that you want to end up getting the same base on both sides of the equal sign. Once you have that, you can drop the bases, meaning you just kind of cancel them out, and then you can solve the equation and get x equals 5. Okay, so on example 1, it has 3 to the x power. Can we write 81 in terms of 3?
Yes.
Good, it's 3 to the 4th. And if you need to break it down, 81 is 9 and 9. Each of the 9s are 3 and 3. So 3 to the x equals 1 over 3 to the 4th power. But that's still not really helping me because the 3's aren't really in the same spots. So if I want to end up bringing that 3 to the 4th to the top, what do I do? Exactly. So it becomes a negative when we bring it up. So 3 to the x equals 3 to the negative 4th. Now that both the 3's are in the right spots, these cancel and the answer is x equals negative 4. So now it's your turn. Try example 2 on your own. Yeah.
3 equals
Wireless is not the answer.
Yes, it is. When it comes to air conditioning.
2 to the 3rd is 16, right?
2 to the 4th. No.
I can
No.
solve your issue over there.
Oh my goodness, I don't know what I'm doing. It's okay. Shh. 2 times 2 is 4, times 2 is 8, times 2 is 16, 2 to the 4th.
No?
But, what? Yeah, and you can write your answers on whiteboards. Yeah, that's good. Yeah, if you want to have whiteboards out, that'd be awesome. So the correct answer, just have them out for next time. The correct answer should have been negative 4. 16 is 4 and 4, and then 4 is 2 and 2 and 2 and 2. So we end up with 2 to the x equals 1 over 2 to the 4th power, but we do not want a negative exponent, so we end up taking this and or not negative. We don't want it in the bottom, we want it at the top. So we make it a negative exponent. 2 to the x equals 2 to the negative 4. We can drop our bases, and x equals negative 4. Okay, example 3. This has a base of 2. Can I write 8 having a base of 2? Very good. 2 to the 3rd is correct. So I have 2 to the negative x plus 3 equals 2 to the 3rd. Again, 8 is 4 and 2. 4 is 2 and 2. So 2 to the 3rd. Now that both of my bases are the same, we drop these, and we end up getting negative, and I have x plus 3 equals 3. What would I do now? Good, distribute the negative, so I get negative x minus 3 equals 3. Then what? Add 3 to both sides. Negative x equals 6. And how do I get rid of the negative? Good. So x equals negative 6. Pretty easy? Yeah? What base will I use for example 4? Can I change 2 to be a base of 4?
No.
Good. 2 is correct. So 4 breaks down to 2 and 2, right? So 4 is going to be 2 to the 2nd power. Since you already have an exponent up there, whenever you have an exponent and then another exponent's already there, you multiply them together. So that's going to end up being 2 times x plus 2 equals 2. And then what is the exponent of this 2 on the right side? Very good. It's to the 1st. So you want to make sure you write that, otherwise your equation might not come out how it's supposed to. So now that we have our like bases, these cancel out. So we have 2 times x plus 2 equals 1. What would be my next step? Very good. Distribute the 2. We get 2x plus 4 equals 1. Then we Then we subtract 4 is correct. 2x equals negative 3, and the last step is to divide by 2. So x equals negative 3 over 2. All right, questions? All right, you're going to try example 5 on your own. When you get the answer, you can just write the answer on your board.
Is it x equals negative 1?
All you need to do is just show me on your board, so you're not yelling out answers, so everybody can check. Good, good. Or you can show me on your fingers, actually, on this one. Good, 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 good.
Wait, did we do?
It's not negative. Good. Okay, number 1. Megasus. Okay, so the correct answer was 1. How many of you got that? Most of you? Okay. So we have 7 to the 2x equals 49 is 7 to the second power. Don't forget that this other part that's up there is in parentheses because you have to multiply it together, meaning that you'll end up distributing. Now I can cancel out my 7s. I get 2x equals, and I'm going to distribute, and we get 6x minus 4. I'm going to subtract 6x to both sides to get all my x's on one side. I get negative 4x equals negative 4, and the last step would be to divide by negative 4 to both sides. So x equals positive 1. All right, what would be my base? Could I write 27 as a base 9? No, good. But we can use 3, exactly. So 9 is going to change to 3 to the second power times 2x, because it's already there. And then 27 is going to change to what? Very good. 3 to the third times x minus 1. We will drop our bases. So now my problem is...
Wait, shouldn't you have multiplied that stuff out first?
No.
By distributing the 2 times 2x?
Well, that's what I'm going to do right now.
I did it different.
Okay. 2 times 2x is 4x equals, and we have to distribute here, and we get 3x minus 3. To solve, I'm going to subtract 3x to both sides, and we get x equals negative 3. Did you distribute this 3 to the x and the negative 1? Are we good? Is that what happened? Okay. Number 7, question. Well, I wouldn't go that far. All right, example 7. What's my base going to be? Not 9.
Three.
Good. So we're going to go to base 3. 81 will be 3 to the 4th power is correct. And then we do a parenthesis x minus 3 because we're going to multiply those together. Equals, what am I going to do with the 1/3? We want to bring it to the top, right? When I do that, it's going to end up being 3 to the what?
Negative.
-1. Because this really has a 1 exponent, right? So we bring it up, we're going to go 3 to the -1 times 5x minus 6. Once your bases are the same, we can cancel them out.
I think this is an easy thing.
Good. And then we'll distribute. So 4 times x is 4x. 4 times -3 is -12. Good. -1 times 5x is good. And -1 times -6 is +6. Okay, then we'll combine our like terms by moving things around. So I'm going to go ahead and add 5x to both sides. At the same time, to save myself a little bit of time, I'm going to add 12 to the other side. We get 9x equals, and 6 plus 12 is what? 18. And then the last thing would be to divide both sides by 9, and we get x equals 2.
I think I know what number 8, we have to have a base of 3.
Mm-hmm. You know the answer for number 8? No. Do you guys have any idea on how to do number 8?
It's 3 to the square root of 3. It's 3 squared 3.
X doesn't equal 3. X is going to equal a fraction.
No, I don't know.
Okay, so the base, though, you guys are right. The base we're going to use is 3, right? Do we all agree that 27 is actually 3 to the 3rd power? Is everybody okay with that? Okay, so I'm going to rewrite this right now as like this. 3 to the x equals the square root of 3 to the 3rd power. Now, I have this root. You can't have a root. Just like we can't have the 3 in the denominator, I can't have the 3 in a root. So we're going to change this to exponent form. Do you guys remember how to do that? So this is a square root, right? So that means that outside of this root, this is really a 2, right? Okay. So remember that this number right here, that is your power, and that right there is your root. Hold on. So when you're writing this, we're going to have 3 to the x equals 3, and then you bring it to a fractional exponent, which will be 3 over 2. This top number is your power, and the bottom number is your root. So now when you drop those bases, my answer is what?
X equals 3 and 2.
That is correct. Now, on number 9, they kind of tricked you a little bit. Because can you simplify the square root of 25?
Yeah.
What's the square root of 25?
5.
5, right? And then there's already 5 outside there, so that ends up really becoming 25. Okay, so I'm going to write this as 5 to the x equals 25.
You can get it to the base of 5.
Very good. So next we would change it to the base of 5. So 5 to the x equals 5 to the 2nd power. And then that means that my answer is just...
X equals 2.
Mm-hmm. All right, and last one, example 10. What base do you think we're going to use on this one? 2, good. Because always think about it, like 4 to the 2nd power is not 8, right? 4 to the 2nd power is 16, so we can't use 4 as a base. So that means that this is really 1 over 2 to the 3rd. And this is really 1 over 2 to the 2nd. But then we don't want the fraction, so what's going to happen?
I have to do the opposite.
Good. So this will end up being 2 to the negative 3 times x equals 2 to the negative 2 times x plus 1. Now that our bases are the same, we can cancel them out. We get negative 3x equals negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. We add 2x to both sides. Negative x equals negative 2. So we divide by negative 1 to both sides. And we get what? X equals a positive 2. Did you have a question? Okay. Does anybody have questions?
Wait, did you just like put the fraction to get the?
So anytime you have a fraction, I can bring this to the top and just change it to a negative exponent. Just like when you have a negative exponent, you can change the side. So we're just changing the side so that, because I don't want it as a fraction, I want it as just a regular 2, and so because of that, I end up changing it to a negative exponent. Any other questions?